Okay, so we've got a pretty big one here. Today we're going to talk about inverses and roots. Thanks for being here. Hope you're all having a great day. Let's learn some math. Remember last video we discussed graphing quadratics for the first time. Something like f of x equals negative 2x squared plus 6. It's a function. We said we'd always put 0 in the middle and count up and down to negative 1 and negative 2. We'd plug in 0 first because it's easy. If you plug in 0 for x, you just get 0 squared, which is 0, times 2 is 0, plus 6 is 6. This is the point 0, 6, and that is our y-intercept. This number right here is always going to be your y-intercept. This is called a constant. A constant is a number with no variable in it, a number that won't change if x changes. Okay, then we plug in 1. If we plug in 1, we get negative 2 times 1 squared plus 6. Remember, 1 squared is not 2, 1 squared is 1. So this becomes negative 2 plus 6, which is 4. So we have the point 1, 4. But that also means, because of the symmetry of these quadratics, we have the point negative 1, 4. If I plug in a 2, I get negative 2 times 2 squared plus 6. I do the squaring first, so 2 squared is 4, and negative 2 times 4 is negative 8, and negative 8 plus 6 is negative 2. So we have the point 2, negative 2, which also means, because of the symmetry, we have the point negative 2, negative 2. Okay, this is 5 pretty points, so I can try to make into a parabolic curve, and that's a really nice one. That's what we did last time. And last time we were told to draw a little arrow here and say that this is both our vertex and our y-intercept. That's the point 0, 6. And also say there's a root here and there's a root here. Well, we don't know exactly where they are yet. Isn't that exciting? Roots are where the graph crosses the x-axis. And right now, we can just see it's like kind of close to 2 and negative 2, but not quite 2 and negative 2. Well, and roots are also x-intercepts. Today we'll talk how to find them accurately, how to actually find their decimal and the exact point, or at least a very accurate version of where those roots are. Doing so is going to involve square rooting, which has the word root in it, because we're finding roots, and it makes all so much sense. But everything is going to boil down to this very, very special word, and that word is inverse. Inverse is how we undo what's been done. Okay? A good word for inverse is also undo. Like in math, if you added 3, the inverse is to subtract 3. Or if you divided by 8, the inverse is to multiply by 8. If you buckle up your seatbelt in the car, the inverse is to unbuckle. And if you make a mess in your room, the inverse is to clean it. Inverse means undo. Now, not everything in the world, not everything in life has an inverse. But most things in math do, and that's quite nice. Okay, so inverse is a very, very, very important idea in math. Every operation has an inverse. We use inverses when we solve, right? Like here we have subtraction, x minus 9. The inverse of subtracting is adding, because adding undoes subtraction, and we solved x equals 21. And here we would do the inverse of adding, leaving us with 6x times 12. Well, this is 6 times x. The inverse of multiplication is division. And we're going to get that x equals 2. Here, the inverse of addition is subtraction. We get 1/2 x equals negative 4. And then this is multiplication, and we can say the inverse of multiplication is division, which, we just did right here. But we could also say the inverse of multiplication is multiplying by the reciprocal, right? Multiplying by 2 is the same as dividing by 1/2. So I could have divided both sides by 1/2, but what's better, I think, is to multiply both sides by 2, and we get that x equals negative 8. So the inverse of addition is subtraction, the inverse of multiplication is division. Well, the inverse of a square is a square root. You undo squares with square roots. So here I have x squared equals 9. The inverse of this squaring, the way to undo this square and get it off the x, is to square root both sides. When I'm solving, whatever I do to one side of the equation, I do to the other, so I square root both sides. Now here's the super important thing to understand. My solution is not just 3. My solution is plus or minus 3. Whenever you square root both sides of an equation, you have to have this plus or minus. So we would say that x is in the solution set of plus or minus 3 because there's 2 solutions. And I square root here, and I get that x is going to be plus or minus 5 because the square root of 25 is 5. So we'd say that x is in the solution set plus or minus 5. Now, 25 and 9 are both perfect squares. When you square root them, you get a whole number. That's what a perfect square is. If you square root it, you get a whole number. When I solve this by square rooting, I'm going to get that x equals plus or minus whatever the square root of 10 is. Now, I'm not sure off the top of my head what the square root of 10 is. I know it's kind of close to 3, but I'm going to calculate it. If I grab my calculator and find the square root of 10, it is only going to tell me 3.16227766, blah, 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 blah. It goes on forever. It doesn't tell me the plus or minus. I have to know that I need the plus or minus. So I can say that x is about equal to plus or minus 3.12, what was it? 3.17, we'll say. 3.16. We have to say it's about equal to because it's not exactly. We have to round because a decimal goes on forever. So our solution set is plus or minus 3.16. But do not forget the plus or minus. The plus or minus is so critical when you're square rooting. Why? Why do we do this? Well, because if we have something squared that equals 100, it turns out there's 2 things that could possibly solve that. 10 can work, but negative 10 can also work, because negative 10 is also, when squared, 100. So you have to have the plus or minus when you're solving. Don't forget it. Don't forget that plus or minus. If x squared equals 30, then x equals whatever the square root of 30 is. .48 plus or minus. If x squared equals 100, x equals plus or minus the square root of 10. No, the square root of 100, which I should just be saying as plus or minus 10. Don't forget that plus or minus when you're solving. Okay, sometimes we have more than just a square happening. If there's other operations happening with this x, like addition or subtraction, we solve using the order of operations backwards. You've probably not thought of this, but when you're solving, you do SADMAP. When you're simplifying or evaluating, you do PEMDAS. Okay, but when you're solving, you do that backwards, you do SADMAP. So first, you deal with any parentheses if there are any, and we don't, no, sorry, first you deal with any subtraction or addition if there are any. In this problem, there isn't any. Then you deal with any division or multiplication. And we do, so we're going to divide both sides by 2. Then you deal with your exponent. That's a square. And the way you deal with that is you square root both sides. So x is going to equal plus or minus the square root of 5. And you can calculate the decimal, but what's nice about leaving this as just square root 5 is that's actually the precise answer. There's no decimal, so there's no rounding, so we can say it's actually equal to this, not just about equal to it. So leaving answers in this radical form is very nice because you don't have to worry about rounding decimals or even finding decimals. Okay, here we add 6 to both sides first. Gives me x squared equals 16. Square root both sides, and x equals plus or minus 4. So x is in the set of plus or minus 4. This one has a little bit of everything happening. I've got multiplication, I've got an exponent, and I've got addition. I'm going to have to deal with all of these SADMEs. I don't need the p, there's no parenthesis anywhere. So first I deal with addition or subtraction. So I'm going to get rid of this 12. That gives me negative 3x squared equals negative 12. Then I deal with multiplication or division, so I divide both sides by negative 3. And that gives me x squared equals 4. Then I'll square root both sides, and I get that x is plus or minus 2. It's beautiful. Okay. Finally, we're going to use square roots to find the roots of quadratics, find the roots of these parabolas. So I'm going to graph this parabola right here. I'm going to do this fairly quickly, okay? So I plug in 0, I get out -6, that's the y-intercept. My next points are going to be here, and my next points are going to be here. I can keep going. I've got a point here, and here. This is the graph of y equals x squared minus 6. Well, we know that the vertex and the roots, the vertex and the y-intercept are right here at the point 0, -6. What we want to find is this root and this root. Well, now we can find them very precisely. Solving for a root with these parabolas just takes a little bit of square rooting. I'm going to take my equation and write x squared minus 6 equals 0. So I'm going to change the f of x to a 0. X squared minus 6 equals 0. And then I just solve this. I add a 6 to both sides, and I get that x squared equals 6. I square root both sides, and I get that x equals plus or minus the square root of 6. If I want to calculate that decimal, I'll do that correctly somehow. The square root of 6 is going to be pretty close to 2, I think. Almost 2.5, 2.45. The roots are just about plus or minus 2.45. So one of my roots is at 2.45. The other root is at negative 2.45. I wrote that one backwards. So to find roots, you just do some square rooting. Just do a little bit of solving. It's really quite simple. We'll do one more just, because we're having fun. Here's negative 2x squared plus 5. If I plug in a 0 for x, I'm going to get out a 5 from my y-intercept. There's going to be points here and points here. So there's 1, 3, and 2, negative 3, and negative 1, 3, and negative 2, negative 3. So this parabola goes like so. It's going to have roots at like negative 1.5 and positive 1.5-ish. But I don't know exactly what they are, and I want to find them. So I'm going to take this and set it equal to 0. Subtract a 5 from both sides, so I get negative 2x squared equals negative 5. This is me finding the roots, by the way. Divide everything by negative 2. We get that x squared equals 5 over 2. I'm just going to call that 2.5. Okay, well, if x squared is 2.5, I want to find x. X is the square root of 2.5. 1.4-ish, I bet. Maybe 1.5-ish. Square root of 2.5 is 1.58. So one of my roots is at 1.58 comma 0. The other root is at negative 1.58 comma 0. The vertex is 0, 5. Okay, we're talking a lot more about square roots, inverses, plus or minuses, all kinds of good stuff. But that's enough for today. So let's just kind of get a recap here real quick, which I don't have space for. Where can I find space? I'm going to recap over here. Recap. The word inverse means undo. Roots are found when you take your equation and set it equal to 0, then solve. Anything else? Whenever you're solving, you do SADMAP. Well done. Till next time.